Alright, lenses and mirrors. This page is pretty easy actually. As long as you've done the reading, it's easy. And then don't forget to use the websites on Canvas because they have some good stuff you just sort of got to navigate through. So, let's get started. Types of mirrors. You have convex mirror, plane mirror, and concave mirror. So, let's go over this. Obviously the easiest one is a plane mirror, what you're used to seeing every day. It's just a flat mirror, right? So let's go ahead and mark that one because it's easy, right? Now let's look at convex and concave. Some of you guys know this instantly because it's also easy, and some of you don't know it. So if you have checked your website, the one I have on Canvas, the physics classroom, you can get a good answer. Relative to the person, the girl here, concave is like a cave. So if you could set yourself in it like a bowl. So that's bowl shaped, whereas convex is like a hill. Remember, this is relative to the girl. So you could stand on a convex mirror and it would be shaped like a hill. Another thing to look at is the unit, where they sort of give us the answer here, where you see the two types of spherical mirrors. Converging, which is a concave mirror, looks like this, relative to the arrow, right? And diverging, which is a like hill-shaped sort of hill or mirror, and that is a convex. So again, concave is like a bowl, convex is like a hill. Okay? So with that being said, convex would be a mirror that curves out, sort of like this. And concave would be a mirror that curves in, sort of like this. And that is going to be like a bowl. So that's the first part, and let's keep rolling. So that's pretty easy, cab. Okay, so plane mirror, again, is flat. Alright, circle the correct word. It's not numbered, but it's this one right here. Circle each word that is correct. Mirrors blank, light, and lenses blank. So a mirror reflects light, and lenses refract light, so sort of like shift it, right? So that one's pretty easy. You can see the diagram sort of here. Mirrors reflected an angle, and then depending on the curve of the mirror, the curve of the lens, excuse me, it will refract it. Okay, so law of reflection. That's on this page, right here. So the law of reflection pretty much states that the angle a light ray hits a surface is going to be the same angle that it is reflected, as long as it's a flat mirror, right? So, let's look at this. The law of reflection says that whatever angle, and we're going to go back over this when we get to here and then here, the light ray hits the surface at equals, meaning it's the same, is the angle that it is reflected, meaning it's like bounced off, right? The angle, the coming in angle, is called the incident ray. And it strikes the mirror, while the reflected ray is the one that bounces off. So that's easy, reflected. A lot of these are repeat words. Okay, so let's keep. Okay, so next blank. The normal line is the imaginary line. This is important. That is perpendicular to the boundary line. We're going to go over that, and we're going to kind of sort of look at an image in a second. Perpendicular with a C. Cool. Between the boundary line, between the two materials at the point where the light goes from one material to another. So, let's look at that in the notes, just so we can make sure we got it. So, the angle of the beam light makes when it strikes a surface is described with respect to the normal. So the answer is right here, an imaginary line drawn perpendicular to the surface. So perpendicular sort of means like at a 90-degree angle. So if this is the surface, usually they represent an imaginary line as a dotted line. This would be the normal line, right? Okay, so we're going to use that again here in a little bit. So the normal angle is the imaginary line. It's always perpendicular. So if our actual surface was here, perpendicular would be like a 90, would be here. If our surface was here at an angle, perpendicular still would be 90 to that angle, which would be about here, right? So that's how you know what the normal is. All right, versus the incident. Okay, so let's skip down to the bottom and do one of these bottom ones. It's actually pretty easy. So bottom one, remember we got to label the following. We have to label the normal, which we just went over, the boundary line, the incident ray, and then we're going to draw the reflected ray, which is not here. Notice it's going to say get a protractor, so we'll actually need to get a protractor and measure the angle of the incident ray, which is like the coming in ray, right? So let's label everything. On my sheet it's colored, so the light going in, which is the incident ray, is blue. Yours is going to be gray, but it's going to be kind of cloudy gray. So this is going to be our incident, right? And remember, the incident ray is the ray that strikes the mirror, right? The light ray coming in. The imaginary line that's perpendicular, meaning it crosses the surface at a 90, that's going to be our normal. So that's right here. So all these blue are going to be the incident rays, and then the normal imaginary line is going to be always the dotted line, right? The boundary line is the line that's like, it's pretty much the surface, right? That's getting light's hitting it and bouncing off. So this is going to be our surface or boundary line. And then the degrees which you would measure, you'll put a protractor. I'll sort of draw in the protractor. I would just set it on the boundary line. It's going to be right here, just like it is. I'm going to do sort of an estimate, but I want you guys to measure it with your protractor. You know this is 90, right? So you know it's going to be less than 90. It has to be less than 90. So I'm going to estimate and say this is about 43 degrees or so. Use this as sort of your base to measure all these. Remember, you line your protractor up on the boundary line, right? You don't want to line it up on the normal. This is the bottom of my protractor. You don't need to label this, but just to kind of get a point of reference. So, like I said, I estimated this one, measured out with your protractor. You might get a little more, a little less than 43, but it should be pretty close to that. Knowing that this right here is a 90, it's got to be less than that. And it's about half of 90, which is about 45, a little bit less, 43. So, okay, let's come back up. We're going to jump back up here. So write yes if the law of reflection applies to that kind of mirror, and no if it doesn't. So let's go back to our notes. So what we just said with the law of reflection is when light shines onto a mirror, the angle at which the light enters the mirror is exactly equal to the angle at which the light leaves the mirror. That's the law of reflection. So the angle at which the light comes in, if this is our boundary line, is going to be exactly equal to the angle at which it leaves. Easy, right? Now, let's bounce back down here. Due to the curvature of a spherical mirror, meaning a concave or convex, light reflected from its surface behaves somewhat differently than it does when reflected from a plane mirror, meaning that it doesn't behave the same when you bend the mirror, right? So with that being said, when you see right, yes, if the law of reflection applies, we know it applies to a plane mirror, so that's going to be yes. And no if it does not apply. Well, both of these are bent mirrors. Convex is like this, it does not apply. And concave, like a cave, is like this, and it also does not apply because it's a bent mirror, right? Okay, predict the angle of reflection for the following incident angles on a plane mirror. This is super easy, even though it looks hard. Just remember the law of reflection. If it's a plane mirror, which it says right here, it's a plane mirror, then the light ray hits a surface is going to equal the angle which is reflected. So if it hits it at 30, what's it going to reflect at? 30, right? If it hits it at 120, it's going to reflect at 120, so on and so forth. So these are all very easy. If it hits it at 73, well, it should reflect at 73. You can always estimate these angles, because if you think of a protractor like this, right down the middle is going to be 90. So if it's somewhere between here and here, it's going to be between 0 and 90. If it's somewhere between here and here, it's going to be between 90 and 180, right? So that's easy to kind of estimate these. All right, so that's this page. Pretty simple, pretty straightforward. Hopefully you guys got it. Let me know if you got any questions.